Now from this approximate equivalent circuit, we can write this voltage equation as shown in equation 1. The applied voltage V1 is equal to the secondary voltage V2 prime. Prime means this quantity has been referred to the primary side, plus I1 multiplied by R equivalent plus Jx equivalent. Now this figure shows the phasor diagram. So we are taking the secondary voltage as the reference. We have assumed a lagging load so that the load current I1 lags the secondary voltage by an angle of theta. So we are trying to draw the phasor diagram from this equation. So V2 prime plus I1 into R equivalent plus J into I1 into X equivalent gives you V1. Now from this phasor diagram, we can split this applied voltage V1 into two components, one V cos delta along V2, and that is nothing but V2 prime plus I1 R equivalent cos theta plus I1 X equivalent sin theta. Similarly, there will be a component of voltage in quadrature with V2 prime, which is given by equation 3. Now, normally, under normal operating conditions, this angle delta is very small, so that this term V1 sin delta is neglected often in calculation, and V1 cos delta is approximated as V1, which is equal to V2 prime plus I1 R equivalent cos theta plus I1 X equivalent into sin theta. Now, using this equation, you can find the voltage drop as a percentage or per unit of the applied voltage or the voltage under no load condition, which is termed as the voltage regulation, and this expression 4 gives you the relationship. Now while conducting the experiment, you need to connect the circuit as given in the connection diagram. So you will use a single phase 50 Hz supply which will go to a single phase variac. The output of the variac will give you a variable single phase 50 Hz AC supply. You will connect an ammeter to measure the input current, a voltmeter to measure the applied voltage, and a wattmeter to read the input power. On the secondary side also you will connect an ammeter, a voltmeter, and a load bank, a variable load bank. We have used a resistive load bank for our experiment where you can add loads in steps. Now please note that had you been using an inductive load, you needed to insert an ammeter, a wattmeter, or you needed to replace the voltmeter and ammeter using a wattmeter for inductive loads. Now for the process, once this connection is done, you will apply rated voltage on the primary and you will start applying loads in steps. So first you will insert this load R1 into the circuit. You will take down all the meter readings. Then you will gradually increase the loads in steps while ensuring that the winding current never exceeds the rated current of the transformer. And then once you have conducted your experiments, you can calculate efficiency and voltage regulation at every step of load variation. Experiment for conducting load test on a single phase transformer. We have a single phase transformer of 1.5 kVA rating. The rated voltages are 110 volts and 220 volts on the two windings. And we also have a load box with the help of which we will vary the loads and apply loads in steps. The equipment we are using are as follows. We are using a variac for applying the voltage. Then we have a transformer which is connected here. The terminals have been brought out. Then on the primary side we have connected an ammeter of appropriate rating. We have connected it, as you can see, to 25 amperes because the rated current is 13.6 amperes. We have connected an wattmeter for measuring the input power, and we have also connected a voltmeter to measure the input voltage. On the secondary side, we have connected a voltmeter and an ammeter to measure the voltage and the current respectively, and this goes to the load. Now coming to the connection, as you know, this ammeter is connected in series with the transformer to a wattmeter and the voltmeter is connected in parallel.
Similarly, on the secondary side, the voltmeter is connected in parallel with the load, whereas this ammeter is connected in series with the load. So let's now start conducting the experiment. So as a first step, we need to power this circuit up. Then we need to gradually increase the voltage till we apply a rated voltage to the test set. So as you can see, this is connected to 150 volt range. So we need to increase the voltage till we apply a voltage of 110 volts. So you see right now the applied voltage is 110 volts on the primary side, and similarly on the secondary side the voltage is close to 220 volts. It's close to 220 volts. Now we haven't applied any load, so the current on the secondary side is 0. On the primary side also it's close to 0, but you are getting a very small amount of current which represents the no load current. So let's start applying the load one at a time. So this is the main MCB which I am switching on. Then in steps I am going to apply the loads. This load is rated for 0.25 kilowatts. So I am switching on this load. As you can see, the applied load is very small, so the current is negligible on the secondary side. But there has been a little voltage drop on the secondary side due to voltage regulation. On the primary side, you can see the current. It has moved a little higher than 0, and you can measure the input power on the input side. So let's apply another load of 0.5 kilowatts. Now you can clearly see that the current on the secondary side has increased after applying an additional load of 0.5 kilowatt. Similarly, you can measure the wattmeter readings on the primary side, the ammeter reading on the primary side, and you have to also note the voltages on the secondary side, which has reduced from the earlier value because of voltage regulation. Now let's apply another load. So the total load right now is 0.75 kilowatt. What we are going to do is, since this is rated for 1.5 kilowatt, I am going to switch off this load of 0.25 kilowatt, and the applied load right now is 0.5 kilowatt. You can take another set of readings for each of the parameters that we have mentioned: the input current, the input power, the voltage on the secondary side, and the current on the secondary side. So the applied load right now is 0.5 kilowatt. So let's apply another load of 1 kilowatt so that the total load becomes 1.5 kilowatt. Again, you have to note down the voltage on the secondary side, which has reduced further. It's around 190 volts. You can measure the current on the secondary side, which is around 5 amps. Similarly, the input power needs to be recorded. The input current too needs to be recorded, and the applied voltage also. So this is about the experiment. So we are going to switch off these loads one at a time. So let's switch off these loads. And we are switching off this MCB. So this is about the experiment. After we switch off the load, we are reducing the applied input voltage to 0 and power off this circuit.